Hey guys, in this video we will be talking about the action potentials in cardiac muscle fibers. So we will start with this part of the curve which is referred to as phase 4, and this is when the muscle fiber is in its steady state, that is in its resting state at a membrane potential of -90. And then something interesting happens which is different from how you would draw the upstroke of a skeletal muscle fiber. We have this straight line to show the depolarization, and because this is on y-axis we have the change in membrane potential, x-axis we have time. The fact that it is a straight line signifies how quickly this has happened. So in order to describe this, you have to write rapid depolarization and not just depolarization. While depolarization would have been sufficient to describe the upstroke of, say, a skeletal muscle fiber, it is insufficient for the description of the depolarization in a cardiac muscle fiber, which happens extremely rapidly. And what is the cause? The cause is, at this point, it is at rest. A surrounding myogenic cell, such as a pacemaker cell of SAN, sends an action potential that causes the membrane potential to change to, say, -70 over here, which is the threshold potential. And this, then we have self-sustained rapid depolarization till a peak potential of +20 is achieved. This is a bit different for that of skeletal muscle fibers, which are about +35. Anyways, this is also described as phase 0 or rapid depolarization due to the opening of the activation gate of voltage gated Na+ channel, whose conductance is affected by the voltage. Then we have phase 1, which goes from this point to this point, and this is described as repolarization, because repolarization is basically decrease in the positivity of membrane potential. But we can't just describe this as repolarization or downstroke, this downstroke as repolarization, because this is characteristic for having happened for just a small period of time, and then it kind of stopped and we had this plateau, right? And that is why for complete description we call this brief, because this just took place for a small amount of time, right? And what was the cause for this, right? There was this decrease. The thing is that when there was the reach of -70, there was this depolarization that initiated the activation, the opening of the activation gates. The closing of the inactivation gates of the voltage gated channels was similarly initiated. But this happened much closely and only took place completely by the time peak potential. So in this phase, and this can be taken as a cause of this phase, is that the voltage gated Na+ channels are now closed. So there is no more inward current of Na+ into the cell. So the Na+ cations are no longer contributing positivity to the muscle fiber. In addition, we have cations that are actually leaving. So we have seizure of the inward flow, inward current, and initiation of an outward flow. And which cation is removed? That is the K+. And by which channel? The answer is transient K+ channels that open for this period and then close, which is why we describe them as transient, because they just open for this period and then they close up. So to describe them, you have to mention transient for it to be a complete description. So it's just a limited K+ efflux, because it just proceeds for a short amount of time and ends up closing at end. Then we have a plateau period in which the membrane potential is more or less constant. I probably ought to have made this a bit like this. My apologies. And what is the reason for that? The reason for that is that after this point, obviously the Na+ channels are still closed, so there isn't any inward current due to the Na+. The K+ permeability has been reduced because of the closure of the transient K+ channels, right? In addition to this, the leaky channels, which are normally opened even at RMP to allow the efflux of K+, have closed. So the K+ permeability, and so the outward current of K+ has reduced significantly. Even so, there is some of that still taking place. So this alone does not account for the constancy over here. Something else happens. Calcium inward current begins to counteract the K plus outward current. And because the K plus inward current is quite slight, the calcium inward current needs to be slight as well. And so the type of channels that open are known as slow L-type calcium channels or slow inward current, right? And these sort of mesh up. Now we have phase 3, which is repolarization, the actual repolarization. And it's like repolarization anywhere else is due to the voltage gated K plus channels, right? This is due to the voltage gated K plus channels, right? Added to the fact that the calcium channels have been inactivated. And then we have the RMP phase, in which two things happen. The voltage gated K plus channels of this phase close up and the leaky channels open up again, which closed up during phase number 3, my apologies. Or was it? No, my apologies. It closed during phase number 2, in which we had the plateau. So I'm hoping this was of help. If it was, please like, subscribe and leave a comment.